Hello guys, welcome back to my YouTube channel. Today we are going to be looking at an interesting presentation, which is the differentiation of what? Tangent of x. In the last video, we saw how to differentiate sine of x and cosine of x from first principle. So we are going to look at the differentiation of tan x from first principle as well. If you are new to this channel, kindly hit the subscribe button and don't forget to turn on this notification bell so that whenever new uploads are made available, you will be the first to be notified and you will not be left out, you will not miss out anything. Okay, this is you can use this number and request to join my WhatsApp group, Functional Studies 101. Okay, I am Tengun48 presenting this script, and this is the third series on differential calculus. We are going to release the others subsequently. So note that in this course, this identity, we are going to be making use of this identity most often. Everything, all the rules are derived from here. Okay, make sure you take note of it. So now, without wasting much of your time, I would like us to get into the presentation proper. Okay. Okay, in differentiating tan of x, there are identities that we will use. The following will be used. The first is the tangent of theta, which is the same as sine of theta over cosine of theta. That's the first identity. The second one is the product of a sine function and a cosine function, which is equal to what? Half of this, okay? Or let me say 2 times sine A cos B is equal to sine A plus B plus sine A minus B. So if I want to use sine of A cosine of B, I'll have to divide both sides by 2 or multiply both sides by half. That's the reciprocal of 2. Like I said, whenever you multiply a number by its reciprocal, it changes that number to 1. Okay, good. So we are going to use this identity. The next identity that we are going to use is this one, the sine function being an odd function. It means that the sine of a negative angle will just be the negative sign of that angle. The negative sign will just come outside. Okay, take note of these identities because you will make use of them. The next one is a cosine function. It's an even function. When you want to evaluate the cosine of a negative angle, okay, you will just replace it by cosine of the positive angle. The cosine function takes away the negative sign, it nullifies the negative sign. Then the last identity we're going to use in this presentation is the reciprocal of cosine function, which is secant. Okay, make sure you are following me with a notebook so that you copy down all these identities, so that as we're going ahead, you should be able to have a view of it. Alright guys, in the differentiation of tan x from first principle, we know how it begins, right? We have to look for the difference of f of x plus delta x minus f of x. That's it. So I have to look for that difference. And looking for that difference means that my function to be differentiated is tan x. Okay, so I just come and replace f of x plus delta x. Means anywhere I see x, I replace it by x plus delta x. So that's it I've done for this one. This is f of x plus delta x and minus f of x. F of x is a function that we are differentiating. So now the next step, we are going to use our first identity. The tangent function is a reciprocal, that's the ratio of a sine function and a cosine function, as I gave. So Whatever angle that is here, it will have to be on the sine function and the cosine function exactly the same. Okay, so since I have tan x plus delta x, it will be what? Sine x plus delta x over cos x plus delta x. We are utilizing the first identity, okay, and tan x we know is sine x over cos x. So now the second one, we have to do what? Subtract these two fractions. Whenever you're subtracting two fractions, I want you to know that the product of the denominator is always a common denominator. Okay, so this time this is a denominator of your fraction. You just have to draw this line and you put your denominator as a product. Then now, to know what is here minus what is here, you have to do a cross multiplication. This time this. Are you seeing? Cross now, like a cross. This time this, then this time this. Maintain the negative sign. So this time this, I have to write the sine function first so that it will suit the second identity because we have to use it. So I have sine x plus delta x times this one cos x minus, okay, you maintain the negative sign. If it was addition here, you maintain the addition. But note, if it was multiplication, you don't do this, okay? The way you multiply two fractions is totally different from the way you add or subtract two fractions. So now, minus this times this. So I have sine x, write sine x first, times this one, cos x plus delta x. Then the denominator is just the product of the two, like I said. Then now, in the next step, we are going to use this our identity that I said I gave you earlier. To use this identity, you have to make sine A cos B the subject. That's, you have to change these two to 1. To do that, you multiply A by half, okay? Any number multiplied by its reciprocal is 1, okay? It's 1. So it means that since it's an equation, to make it, to do manipulations on it, I have to do it throughout the equation so that it will remain unchanged. I'm multiplying every term in this equation by half. So I'll multiply it by half, it will go away. So there will be a half here and there will also be a half here. Okay, so we're going to use it here in this first part. You can see that we have a product of a sine function and a cosine function. So it suits this form. So we're going to use this identity with the halves involved. Okay, so the first part, this is the first part. Remember, there are halves here when you are using the identity. You divide both sides by all through by 2, or you multiply all through by half, each term by half, no problem. It's the same thing. Okay, so my A in this identity, this first one, this first two term is x plus delta x. Okay, then my B is x. You can see clearly. So I have to replace it here. There is a half here. This is a half I've already copied. Okay, sine A plus B. My A is this and my B is this. So I have x plus delta x plus x. That's B. That's the first part of this result. Remember, it has two parts, plus B plus sine A minus B. So plus half. Remember, we divide all through by, multiply all through by half before we use the identity. So there is a half here. So the half, this is a half, sine A. This is supposed to be what? X plus delta x. Sorry, is a typing error. So this is x plus delta x minus B. B is what? X now in this first term. Okay, good. Then now you do the same thing for this other term. This is a product of a sine function and a cosine function. So I come here, remember there is a negative sign, so each of these terms will now be negative. So I have negative half sine of what? A plus B. Okay, this is my A and this is my B. So we'll be having x plus delta x. So it is the same thing, x plus delta x, even if you write delta x plus x. In as much as they are all positive terms, does not have any issue. Okay, even if they are negative, there is no issue. Addition is commutative. Addition of two numbers is commutative. So if you have negative 2 plus 1, it will not change the fact that I have 2 plus negative 1. If you have negative 2 plus 1, the result will not change if you take 1 plus negative 2. Okay, it will still remain negative 1. So that's it. This is the first part of this one now. Minus again, because of this negative sign, each of the term will be negative now. Half, the half that we divide now, when we divide by 2, there is another half there. Then divide a minus b. My a is x and my b is what? X plus delta x. You replace. So you have x minus x, as you can see, minus now. This is x now. That's a minus all of this angle. So you distribute a negative sign. Each of them will be negative now. Minus x minus delta x. All you have to do now is to simplify this. And doing that, you have x plus x is 2x. Then delta x remains. Down here, x minus s is 0. Okay. Remember I told you that this one was plus here, not minus. So you have plus delta x left. For this first two terms, the second one, x plus x is 2x. Then now we have delta x. Then here we have s minus s is 0. And you'll be left with sign of negative delta x. We will now use the third identity that I gave you. The sign of a negative angle is a negative sign of that angle, right? The negative sign comes out. So if this negative sign comes out, it will become what? Positive here now. So that's why we have positive here. That's why we have this positive half instead of negative half now, because the negative sign will come out and multiply it. Okay? And you'll be left with what? The sign of the positive angle, sign of delta x. The denominator remains the same. Students, I will recopy the identity from the previous slide so that we simplify it together. Okay, so doing that, I have this. Now, what you have to notice here is that this term, this first one and this third term, this one, they are identical. Can you see that? We have half sine 2x plus delta x, then minus half sine 2x plus delta x. It's exactly the same thing, but they have opposite signs, so they will cancel out each other. So these two terms will go. You'll be left with half sine delta x plus half sine delta x. Half plus half is what? Half plus half is, if you wish, 2 over 2 is 1. Half plus half is 1 now. So at the end of the day, we'll be left with delta, sine of delta x at the numerator. Okay, because now the coefficient will be 1, not half again. Half plus half is 1, and the denominator remains the same. Like I said, now in step 2, after you've gotten this simplified version of the result, okay, you now have to divide this result by delta x. Doing that, I have this my result. Copy it the way you are seeing, and it's divided by delta x. To divide these two fractions, you multiply the numerator by the reciprocal of the denominator. When I talk of reciprocal, it means 1 over that thing. The denominator is what? Delta x over 1. Okay, that's a fraction, as a fraction. Then now the reciprocal means you swap the numerator and the denominator of that fraction. Delta x over 1, when you swap it, the 1 will go up at the numerator and then delta x will come at the denominator. So you'll be having 1 over delta x. So that's the reciprocal. You can use the normal techniques that you know how to do to divide two fractions, and you still end up having the same thing. It's exactly the same thing that I'm saying in other words. Okay, so I have what? Sine delta x over this, my first fraction, that's the first fraction, and multiply the numerator of this my fraction. The numerator is actually a fraction by the reciprocal of the denominator. That's what we have. Then now we just do some arrangement. this sign can come here and 1 can come here. Okay, that's just to create this nice expression that we will use. Then from there now we have to take a limit as delta x tends to 0. Okay, that's the last step in looking for the dy by dx, where y is a function of x. So looking for that limit, I have to know that this is a product of two functions, so the limit is distributive. The limit operator is distributive over multiplication. So we're going to have limits as delta x tends to 0 of this first function times the limit as delta x tends to 0 of the second function. And we all know, we have accepted, all of us, that this limit is 1. As delta x tends to 0, it means delta x is small. So sine of a small angle gives that same angle, right? From the previous videos that you have watched. If you have not watched, you go back and watch it. Differentiation of sine and cosine. All these things were explained there detailedly. So if delta x is small, then sine of delta x will be what? This angle will be what? Small now. If delta x is small, sine of delta x will be delta x divided by delta x is 1. And the limits, okay, the limits of a constant is that constant. So all of this thing here is equal to 1. For this part, we just have to replace our delta x by 0 and we are done. Okay? Doing that, you have to notice that when you replace by 0 here, you'll be left with x here. So that will be cos x times cos x. Okay? Cos x times cos x, which is what? Cosine squared x. Okay? This is cosine to the first power, this is cosine to the first power. So according to laws of indices, you have to what? Multiply the when you are multiplying two terms with the same denominator, the same base, you add their powers. The base is cos x and the power is 1. So now add 1 plus 1 is 2 now. Yeah, so that's why I have 1. This is my 1 there. Divided by cosine to the second power. And the reciprocal of cosine we said is secant, right? And you square the result, now you get secant square. That's the final answer, guys. So that's how you differentiate. So from this video, you should note this theory result. Derivative of sine function is cosine. Derivative of cosine function is negative sine, and derivative of tangent function is secant squared. Very important. You will use it throughout. Okay? And mind you, this type of questions can come for high marks. Differentiate, they precisely differentiate from first principle. Students are neglecting this section. And when they enter the hall and see questions there, they are like, why did I not study it? Regrets. Had I known, the words of a fool. Anyway, that's the end of the video. Thank you for watching, and I believe this video has helped you understand some certain things. If you don't understand anything, the comment section is open. Feel free to drop anything you want to drop at the comment section. And also, if you don't understand anything, you can get to me on WhatsApp using the number I highlighted on the screen, and we got to chat better. See you in the upcoming video. We have come to the end of our presentation. What is coming up next? We have the different techniques that we'll be using in differentiation. And we'll begin from the chain rule. Afterwards, I will give you what will be coming next. So stay tuned and don't forget to share, okay? I want to thank you, use this opportunity to thank you for your kind attention, and hope to see you in the next presentation. Bye-bye.